All right, we're going to begin with 11.3, which we're going to be talking about rotations. As you can see in our let's do it that way. As you can see in our paper, we want to take a point. Let's call it, A, B, and we're going to rotate this around the coordinate plane in 90-degree intervals. "90-degree intervals are important as we move on into the pre-calculus world, the calculus world, and things of that nature. So being able to rotate something in 90 degrees is always going to be very advantageous for us. You can also go the opposite way, 90 degrees. And get around to the same point. If you do that 4 times, and then we spend a lot of time worrying about the language about a rotation to 180 or the rotation for 270. What I like to be able to do is take this particular point and say, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, within those quadrants, what we're allowed to be able to do is we're allowed to be able to say, okay, well, if those are the quadrants, then this has a plus x and y. This has a minus and plus x and y. This is a minus x and y. And this has a plus and a minus x and y. So as you look at the rotations, the rotation of the points, every time you go 90 degrees, you flip the x and y. So that might be a point of interest to some of you to jot down as a note. So we're going to write that over here on the side. So every time you move 90 degrees in either direction, counterclockwise that way, or clockwise that way. Those kind of look kind of weird, to be quite honest with you. We will erase those. We're going to do a switch of the x's and y's. There will be a switch. Oops. There is a switch of the x and y coordinate. So as an example, 2, 4, switching the x and y's goes to 4, 2. And then what it does is it becomes, okay, well, if this starts at 4, 2, and I rotate it 90 degrees into that quadrant, we're going to switch that to 2, 4, but this x value is going to be negative. And the reason for that is because it's in the second quadrant. All right, so if I start from the first quadrant, I go to the second quadrant, we're going to flip the x's and y's, and then we're going to become a negative x value. If I go another 90 degrees, the coordinate is going to be 4, 2, but now I know both coordinates are negative because we're in the third quadrant. And then if we go another 90 degrees, we know that it's going to be 2, 4, and then my negative value is in the y coordinate because of the x value or the y value being negative. So it's really more about locating where your point is in the particular scenario. Okay, so what I'm going to do is I'm going to come over here. I'm going to demonstrate that just a little bit here with my own coordinate plane. So I'm going to draw a random coordinate plane right here. And I'm going to put a point of, let's just put the point right there. And let's call this -6, 1. All right. So let's say that my movement wants to go 100. Let's just start with 90 degrees clockwise. Okay. Clockwise means it follows the clock. So if that's the case, then my movement is going to go from 1, 6, and I just have to figure out if I'm in the second quadrant, 90 degrees clockwise is going to put me in the first quadrant, and my x value and my y value are positive, positive, positive. Okay, if I wanted to move this 90 degrees counterclockwise, that means we're going to go from the second quadrant to the third quadrant, and we're going to move that point to here, and that point's going to be 1, 6 as the values, but now we're going to do -1 and -6 because we're in a negative situation. Okay, so that scenario gives you the concept, and what I'll try to point out to you is that this is a 90-degree rotation. All right, 90 degrees rotated this way, right? And then we have also a 90-degree rotation here, which is considered that right there. So that scenario for 90 degrees, it creates a scenario where we can rotate the objects. Okay, so now we have to go to the picture with the exercises, right? And we're going to be looking at taking this picture, and we're going to rotate this bad boy 180 degrees. Well, 180 degrees is how many quadrants away? So we really want to just talk about the number of quadrants. This is 2 quadrants. 2 quadrants in either direction. All right. So for instance, if J, for instance, is in quadrant 2, all right, and J is going to be 2, 4. Well, 180 degrees will go from quadrant number 2 to quadrant number 4. Okay, so that's 2 switches. So we go from 2, 4 to 4, 2 to 2, 4. And now because we're in quadrant 4, actually this is -2, by the way, right? So we are going to then be in a plus minus situation. So that bad boy J prime is going to be 2, -4 because we're in the fourth quadrant. All right. So that movement created a 90-degree movement. M is 1, 1. So M prime is going to go along that scenario. It's in quadrant 1. It will go to quadrant 3. and we will line up here in M prime. All right. K is in quadrant. Let me actually change the colors on these guys here, these originals. So the originals are right there, and right there, and my red will be the points. So K is in the second quadrant. 180 degrees moves it 2 quadrants. So we're going to move this over here. This is -5, comma 1. So -5, comma 1. If that's my original point, is going to go to 5, -1, because the x value is positive and the y value is negative. So that value is going to be right there. That's going to be K prime. So that 2 quadrant movement will do that. So then we go to the value of L, and that's going to be, L is going to be -2, -2. And that's going to move 2 quadrants from quadrant 3 to quadrant 1. And that's going to end up being right there, L prime, all right, which is in quadrant 1. So now my rotation is there. Okay? All right, hold on just a second. So it's a little easier to do within points. So rotations can be difficult, but if you think in quadrants, it becomes a little bit easier. All right. So again, I'm going to highlight my points here in blue. All right. And we're going to move along these points. 90 degrees. 90 degrees is that way. Doesn't actually say which direction. So we're just going to assume it goes to the clockwise direction. So again, it's better if I move things by quadrants. So I'm going to be going from quadrant 2 to all of these points are either on the axis line or in quadrant 2. So they're going to all go to quadrant 1. Quadrant 1 has a positive value, where this has a negative positive value. So when I do a -1, comma 4 for that particular point, -1, comma 4 for that point. So this value goes to 4, 1. 4, 1. And you see, all right, that scenario goes from here to here. Okay, that rotation of 90 degrees. Okay, you switch the X and Y and you figure out what quadrant you're in. All right, and that's the most important thing that we do. Okay, so, you know, this point is, it looks like this point is -4, 0. All right, we switch and make that point right there, which is going to be R prime. This is S prime. T prime is -5, 1. So we're going to do 1, 5, T prime. And you can see my triangle here. All right, so you're switching from quadrant 2 to quadrant 1. Okay, so 270 degrees is 3 quadrants. So this is in quadrant 1. So we're going to go clockwise again because it doesn't tell us which direction to go. And I'm going to switch that all the way over to quadrant 2. I screwed that up. So if I go to quadrant 2, that's 3 switches of the 3 switches of the X and Y coordinate. So for instance, if I'm in the easiest coordinate to think about in this case is probably B, just because it's 4, 3. So if I do 3 switches, one switch is going to be 3, 4. Then I'm going to go 4, 3, and then I'm going to go 3, 4. All right, so it's 1 switch, 2 switches, 3 switches, 3 quadrants that we moved. So this represents 1 quadrant here to quadrant 4, a second quadrant here, which is quadrant 3, moving into quadrant 2. So 1, 2, 3 quadrants that we moved. 1, 2, 3 switches. So now, because it goes from 1 to 2, the objective of the point is just to make the X value negative. So we know that B prime is going to be negative 3, 4. B prime. All right. A is 1, 4. So this is going to go negative 4, 1. A prime. Okay. D is 1, 1 or 1, 2. So we're going to switch that to negative 2, 1. And then C, and I'm going to write this one out just because it's somewhat hard to follow if you don't write it out. C is 3, 1. We switch it 3 times to 1, 3, and we make the X value negative because we're in quadrant 2. So it's negative 1, 3. So this is going to be, let me enlarge this a little bit so you can see it. That's going to be C prime. Okay. So we now can take this guy and you can see that rotation that we're talking about right there. Okay. So again, we're looking at these rotations. So this one wants us to do a composition of a reflection and then a rotation. Okay, so if I'm going to reflect this, this is gonna be a double whammy here. Okay, and I don't really want to talk about this, but I'm gonna do it anyways because I think it's valuable to think about. So if I'm going to go across the x-axis, I'm going to go to n prime, and then m prime is going to be right there. So we have n prime and m prime. Okay, so it's always good to do m prime and then label the points, which is negative 4, negative 4. And then n prime, which is going to be negative 2, 2, negative 1, 2, negative 1, 2. All right, so now 180 degrees is 2 quadrants. So now these guys, this is quadrant 2, quadrant 3. Quadrant 2 goes to quadrant 4. That's 2 switches. So 2 switches for n gets you back to n double prime of 1, 2. But since we're in quadrant 4, it's going to be a positive x with a negative y. So we rotate, that's going to be 1, negative 2. So that n double prime is going to be right there. Okay. And then what we have is m double prime, which is 2 switches. So it's going to be 4, 4. That's going to go to quadrant 1, which is positive, positive. So that 4, 4 is going to be right there. M double prime. So you can see that actually reflection and rotation is almost going to be like reflecting it along the y-axis. It's kind of weird. Okay, it's not kind of weird. It's just kind of a little bit. So now this one wants you to do that. That's I'm not going to necessarily do that thing. So now we're looking at these rotations. I'm going to skip down here to a translation. So we want to graph 2, 3 in the. So I'm going to go up here. We'll go count by ones here. So this is J. K is 1, -1. K. And L is -1, 0. All right. So we're going to move this guy 4 up and 4 down. Or 4 to the right and 4 down. So the first translation in this particular beast is going to be 4 left, 4 left, and 4 down. All right, so we're going to do 4 left, 1, 2, 3, 4, 1, 2, 3, 4, L prime, and we're going to write that as -5, -5, -5, -4. All right, that's L prime. K is going to be 1, 2, 3, 4. 1, 2, 3, 4, and -5, -4. So that bad boy is going to be right there. K prime, which is going to be -3, -5. And then J is going to be 1, 2, 3, 4. 1, 2, 3, 4. So this is going to be right there. That's going to be J prime. And that's going to be -2, -1. Whoa. So there's my triangle. Okay, so that triangle is going to be L prime, K prime, J prime. And now I'm at 270 degrees. That's 3 times around 3 values. They're all in quadrant 3. So we're going to all put them in quadrant 4. We're going to go clockwise around there. So quadrant 4. Okay, so now going to move that 3 times around. So let's switch. So it's going to be +1, -2, +1, -2 for J prime. J double prime. Okay, so that's 3 different things. Oh, no. It's not 2. That's not right. It's a half. Whoop. So that's going to be +1, 2. Sorry about that. +1, 2. This is where J double prime is. All right, then we're going to do 1, 2, 3, switch 5, 5, -3. So 1, 2, 3, 4, 5, -3 is right there. That's going to be K double prime. And this is going to be 1, 2, 3, 4, -5. So 4, -5 is going to be right there. That's going to be L double prime. So my rotation is going to be based off of those coordinates. So this rotates into that. Okay. So you can see kind of how that works. And then we talk about rotational symmetry. Determine if the figure has rotational symmetry. If so, describe any rotations that map itself. So basically, if this is a symmetrical figure and I can draw a line through that and I can rotate it around, if I rotate it 360 degrees, right? If I rotate it 360 degrees, it looks the same. Well, if I only rotate it to here, it also is going to look the same. So what is the angle of rotation there? Well, you just 1, 2, 3, 4, 5 rotations, divide that by 5. That's going to be 72 degrees. So every 72 degrees, that thing rotates around. I'm not too concerned about that. I'm more concerned about you being able to move the points successfully. And there you have it.